Okay, let's dive in. Think about Colorado. Lots of sunshine, those big blue skies,
Yeah,
right?
famous for it.
But at the same time, it's a place really grappling with water scarcity, which feels like a bit of a contradiction.
It really does, and that's kind of the core tension this recent report we've been looking at tackles. It's exploring how Colorado is trying some really innovative things with solar power.
Things that connect solar with, well, with rain and water,
Yeah,
basically.
we've got this white paper that goes into detail on strategies linking solar panels with precipitation tech and water bodies. It's pretty fascinating stuff.
Okay, so for this deep dive, our mission is really to unpack the key ideas from the source. We want to understand how Colorado is trying to make energy production work with water conservation and maybe even help out agriculture too.
Yeah, they're sort of branding it rain-powered solar, though, it covers more than just rain.
Right.
So the source really emphasizes this dual reality for Colorado. You've got like amazing solar potential over 5.5 peak sun hours a day on average,
Yeah.
but also this huge pressure on water. Traditional power and farming, they use a lot of water. So the report looks at systems that do both generate power and interact positively with water.
Dual use systems, basically. And the source mentions a few specific approaches.
It does. The first one, and maybe the easiest to picture, is agrivoltaics.
Ah, yes, putting solar arrays over farm fields.
Exactly. And the report gets into why this is clever beyond just using the same piece of land twice.
Hmm.
It references projects like Jack's Solar Garden near Longmont.
Uh-huh.
Well, the panels provide shade. That shade cools the soil underneath.
Which means less water just evaporating away.
Precisely. It reduces something called evapotranspiration water loss from the soil and the plants.
Hmm.
Research from Colorado State University, highlighted in the report, found it could boost water efficiency by, get this, 157% compared to open fields.
157%. That's huge.
It's a massive number. For you, the listener, it means potentially growing more crops with significantly less water. Really important in a dry climate.
Definitely less water stress. But okay, the report doesn't stop there. It talks about putting solar on water too.
Right, that's aquavoltaics, sometimes called photovoltaics, floating solar panels on water bodies.
And the potential there is pretty big too, I gather.
Huge. The source points out Colorado has about 1,900 reservoirs, and these reservoirs lose, well, an enormous amount of water just to evaporation every year, over 600,000 acre-feet.
600,000 acre-feet. Can you put that in perspective?
Yeah, an acre-foot is enough water to cover an acre of land 1 foot deep. It's roughly what, say, 2 typical households might use in a whole year. So we're talking vast amounts of water just vanishing into the air.
And floating solar panels help stop that.
They significantly cut it down. They act like a lid, basically, blocking the sun and wind that drive evaporation. The report mentions a project in Walden, Colorado, that saw evaporation drop by 70%.
70% again,
Well,
while generating power.
Exactly. The source estimates if they covered just the suitable parts of Colorado's reservoirs, they could save around 429,000 acre-feet of water annually.
Wait, how much is that compared to, say, city use?
Get this, it's more water than all of Colorado cities use municipally in a year, combined.
Wow. Okay, that combination, saving that much water and producing clean energy, that's really compelling.
It's a very powerful finding highlighted in the source material.
But the term rain-powered solar still makes me think about, well, using the rain itself. Does this report touch on that?
It does. That's the most cutting-edge part. It talks about triboelectric nanogenerators, or TENGs.
Tings. Okay, what are those?
So these are devices that can capture the kinetic energy, the energy of motion from raindrops hitting a surface and turn it into electricity. Think of it like a tiny generator activated by the physical impact of the rain.
So you're actually generating power from the falling rain itself.
That's the idea. It's still more experimental for large-scale use, but the source mentions promising lab work, including tests at CSU on solar panels coated with TENGs.
Hybrid panels.
Yeah, potentially combining standard solar cells with a waterproof TENG layer. In tests, these showed about a 10% extra energy boost while it was raining.
Which could be handy in Colorado with those afternoon thunderstorms they get.
Exactly. Capturing a bit of energy even when the sun isn't fully out.
Okay, so we've got agrivoltaics, aquavoltaics, and now these TENGs. The report covers the tech, but what about, actually doing this? What are the hurdles?
Good question. The source does mention that state policies are starting to encourage these dual-use projects, offering incentives. But there are definitely challenges.
Like what?
Well, public acceptance is one. But maybe more significantly, there are complex legal issues, especially Colorado's water rights laws. They operate under prior appropriation.
First come, first served, basically.
Essentially, yeah. First in time, first in right.
Yeah.
So a big question the legal system is just starting to figure out is who actually owns the water that's saved by floating solar panels? Does it go back to the river or
Ah, I see. That could get complicated fast.
very? But the report also notes that pilot projects, like Jack's Solar Garden, proving it can work economically, and the Walden floating solar showing real results are helping to smooth the path. They provide those crucial lessons learned.
Okay, so pulling these threads together from the source, the farming potential, the massive water saving on reservoirs, the future tech like tangs, plus the legal stuff. What's the big takeaway here?
I think the report positions Colorado's efforts as more than just individual projects. It's suggesting a potential model, a blueprint almost,
A blueprint for what?
for how you can strategically combine solar tech with water management. It's about tackling energy needs, serious water scarcity, which climate change is making worse, and agricultural demands all at once. It's presented as a sustainable path, particularly for other dry regions around the world facing similar issues.
It definitely sounds like a novel way to approach these interconnected problems, but as the source made clear, it's not simple. You've got technical hurdles like scaling tanks, sorting out those water rights, making sure the systems last, which leads to a final thought for you, the listener. Given these complexities, the tech, the law, the social aspects, how might scaling up these kinds of integrated rain-powered solutions require more than just new gadgets? Might it demand a fundamental rethink of how we manage our basic infrastructure, our resources, and even ownership, especially in places facing similar climate and water pressures? Something to ponder.